Have you ever wondered how a simple piece of metal, a magnet, can pull another object toward it, almost like magic? This seemingly magical attraction is a fundamental force of nature that we encounter every day, yet its inner workings are often a mystery. We'll explore the science behind this captivating phenomenon. What gives it this mysterious power to attract certain things while completely ignoring others? Why do some materials respond so readily to a magnet's presence, while others remain unaffected? The answer lies in the intricate dance of atomic particles and invisible fields that govern the magnetic world. The secret lies in an invisible force, a magnetic field. Surrounding every magnet is a region where magnetic influence can be felt, extending outwards in all directions. This field is not something you can see or touch, but its effects are undeniably powerful and far-reaching, dictating how magnets interact with their surroundings. This field can attract or repel objects, depending on the poles facing each other. Just like how opposite ends of a battery attract, the north and south poles of magnets exert forces on each other, either pulling them together or pushing them apart with remarkable strength. This interaction is a cornerstone of magnetic behavior. It's the same kind of force that helps compasses point north, aligning their needles with Earth's vast magnetic field. This invisible shield also plays a crucial role in shaping Earth's own magnetic shield, protecting our planet from harmful solar radiation and making life as we know it possible. Inside every magnet, billions of tiny zones called domains each act like miniature magnets. These domains are microscopic regions within the material where the magnetic moments of atoms are aligned, creating a small, localized magnetic field. Understanding these domains is key to unlocking the secrets of magnetism. In ordinary metal, these domains point randomly in every conceivable direction, effectively canceling each other out. This chaotic arrangement means that the material as a whole exhibits no net magnetic field, appearing non-magnetic to the outside world, despite the magnetic nature of its individual domains. But when aligned in the same direction, their individual fields combine, creating one powerful, unified magnetic force. This alignment transforms the material, allowing its collective magnetic strength to manifest externally, making it capable of attracting or repelling other magnetic materials. This precise alignment turns something ordinary, like a simple piece of iron, into something profoundly magnetic. The process of aligning these domains is what gives a magnet its characteristic properties and its ability to exert force over a distance, a truly remarkable transformation. When you bring a magnet close to a piece of iron, its magnetic field makes the atoms inside that iron start to align. The external magnetic field influences the internal structure of the iron, causing its own microscopic magnetic domains to reorient themselves in response to the magnet's presence. For a moment, the metal itself becomes magnetic, an induced magnetism that is temporary but powerful enough to cause attraction. This temporary magnetization is why the iron is pulled in, as it momentarily acts like a magnet with an opposite pole facing the original magnet, leading to an attractive force. The stronger the magnet, the more atoms align within the susceptible material, leading to a more pronounced attraction. It's not magic at all. It's a beautiful demonstration of physics in perfect harmony, where fundamental forces dictate the interactions between matter at both the atomic and macroscopic levels. We rely on magnetism every day in countless ways, often without even realizing it. From the essential components in electric motors that power our vehicles and appliances, to the tiny speakers in our headphones, the data storage in computers, and even the advanced imaging in MRI machines, magnetism is indispensable. In motors, magnets convert electricity into motion, driving countless devices with precision and efficiency. In hard drives, they store vast amounts of digital information by flipping magnetic directions in tiny spots on a platter, preserving our memories and data. Magnetism isn't just about simple attraction. It's one of nature's fundamental forces, intricately shaping our modern technological world and enabling innovations that define our daily lives. This pervasive force underpins much of our technology, from the smallest microchips to the largest industrial machinery. Magnetism is a cornerstone of modern engineering and science, demonstrating its profound impact far beyond mere attraction, truly shaping the world around us in countless unseen ways. You can see a magnetic field yourself with a simple, engaging experiment. Just place a magnet under a sheet of paper and carefully sprinkle iron filings on top. This classic demonstration provides a tangible representation of an otherwise invisible force, making the abstract concept of a magnetic field visually accessible. The filings will spontaneously arrange themselves into distinct, curved patterns, tracing the invisible lines of force that emanate from the magnet. These patterns are not random. They precisely map out the magnetic field, revealing its shape and direction in a clear and compelling manner. Each curve shows how the magnetic field flows, illustrating the pathways of magnetic influence. This simple yet profound experiment offers undeniable proof that unseen forces are constantly at work, shaping our world and influencing everything from the smallest particles to the largest celestial bodies. From the tiny magnets in your headphones that convert electrical signals into sound, to the colossal magnetic field protecting our entire planet from harmful cosmic radiation, magnetism connects everything. It's a unifying force that operates across vast scales, demonstrating its fundamental importance in the universe. Earth itself acts like a giant magnet, with its molten core generating a powerful magnetic field that extends far into space. This geodynamo guides compasses, allowing for navigation, and crucially shields us from dangerous solar winds and cosmic radiation, making our planet habitable and protecting all life on its surface. The next time you see a magnet stick to your fridge, take a moment to appreciate the intricate science at play. Remember, it's not magic, but rather the elegant and invisible dance of physics that holds our world together, from the smallest atomic interactions to the grandest planetary phenomena. It's a testament to the underlying order of the universe. What everyday science mystery should we explore next in our quest for knowledge? Comment below with your suggestions, and keep your curiosity magnetic, always seeking to understand the wonders that surround us every day.